Conventional lathe machine, also known as a manual lathe, universal lathe, or center lathe, is a fundamental machine tool used to shape, cut, and modify various materials like metals, plastics, and wood with precision. How it works. The basic principle behind a conventional lathe is the rotation of the workpiece against a fixed cutting tool, which removes unwanted material to achieve the desired shape and surface finish. Workpiece mounting, the material to be shaped is secured onto the lathe's chuck or faceplate. Tool positioning, the cutting tool is positioned at a specific angle and distance from the workpiece. Parameter adjustment, the operator sets the spindle speed and feed rate based on the material and desired outcome. Cutting process, the machine is engaged, and the cutting tool, held by the carriage, removes material as it moves along the workpiece, according to textbook. Finishing. Once the desired shape is achieved, finishing operations like sanding or polishing can be performed. Key parts of a conventional lathe machine. Bed, the heavy, rigid base that provides support and guideways for all other components. Headstock, located on the left side of the bed, it houses the spindle, which holds and rotates the workpiece, the motor, and the gearing system for speed control. Tailstock, positioned on the right side of the bed, it can be adjusted to support the free end of a long workpiece or hold tools like drills for operations like drilling or reaming. Carriage, situated between the headstock and tailstock, it holds the cutting tool and allows it to move along the bed, longitudinally, and across the workpiece, crosswise. Lead screw, a threaded rod that runs parallel to the bed, responsible for moving the carriage for precise thread cutting and automated feed operations. Feed rod. A non-threaded rod used for powered longitudinal movement of the carriage and cross slide, according to Mac Power Industries. Tool post, mounted on the carriage, it securely clamps the cutting tool at the desired height and angle relative to the workpiece. Operations performed. Conventional lathes are capable of performing a wide array of operations, including turning, reducing the diameter of a cylindrical workpiece. Facing, creating a flat surface at the end of a workpiece. Drilling, creating holes in the workpiece. Boring, enlarging existing holes. Reaming, finishing and sizing drilled or bored holes. Threading, cutting internal or external threads. Knurling, creating a textured pattern on the surface for grip or decoration. Chamfering, creating a sloping edge or corner on a workpiece. Arting, cutting off a section of the workpiece. Grooving, cutting narrow channels or slots on the workpiece surface. Forming, turning concave, convex, or other irregular shapes. Advantages. Conventional lathes offer several advantages, making them valuable in workshops and small to medium scale production environments.